Hey guys, welcome to my channel. So today's our biweekly contest second problem is maximize the total height of unique towers. So you are given an array maximum height where a maximum height of I denotes the maximum height the ith tower can be assigned. Okay. So your task is to assign a height to each tower so that the height of the ith tower is positive integer and does not exceed maximum height of I. That is the given value. It must not exceed the given indexed value. Okay. No tower have the same height. So basically all the tower must have the unique heights. Okay. So return the maximum possible total sum of the tower heights. If it is not possible to assign heights, then simply return -1. So here in this example, you can see 2, 3, 4, and 3 are the given values in this particular vector, and our output is 10. So what are the unique heights would look like? The first is this 4. Okay, so the maximum height. Then we can take 3 from here. Okay, then we can not take 3. Okay, because see, all the values must be unique, so we have taken 3 from here. So what we can do, we can take one less value from here because we need to find the maximum result. Okay, so we will take 2 from here. Okay, now here, if I take 2, again the both the values will become same, 2 and 2. So I cannot take 2. So what I will do, I will reduce it by 1. It will become 1, and then I will take 1. So it will so that it gives the maximum result. Okay. Here, can I do is I can take 15 only, and I can take 10 because both the values are different when we need maximum height. Okay, so 15 plus 10 would be 25. That's why. Okay. In this particular example, you can see 2, 2, 1 is given. Okay. So if I choose the maximum height from this particular zeroth index, it would be 2. Okay. Then here I cannot take 2 because if I take 2, the two values would become equal. So I will take 1 from here. Okay. Now here's 1. So I cannot take 1 because 1 is already present in our answer vector. So I will take 0. But it is given that the height must be a positive number. Okay. So basically we cannot, so basically it is not possible to take this 0 height. Okay. That's why whatever we will do, we will simply return -1. Okay. So here it's written -1. So what we can do to solve this particular problem? See, it is given that you have to basically find the maximum height. Okay, so by thinking about this logic, you can see that you can find the maximum height if you choose the maximum element in this particular array first. Okay, that is 4 here. After that, the maximum would be 4. So after that, you will reduce all the elements by 1 and then take it. Okay, accordingly. So what I will do is basically I will sort this particular vector in decreasing order. Okay. So if you see this particular example, it would look like 4, 3, 3, and 2. Okay. Then I have taken this answer variable and this temporary variable. Initially, it's containing zero indexed value, that is 4. Okay. Because 4, 3, 3, 2 is the other elements in our vector. Now what I will do is I will check if temporary variable is storing the value that is less than 0. If it is, then I will return simply -1. So it is not 0, it is 4 initially. So this condition won't run. If temp is greater than maximum height of I, that is maximum height of 0. So 4 is greater than 4. No, it isn't. So basically, this condition will also not run. And I will simply add the temporary into our answer variable. Okay, and temp will be decreased by 1 because we have to store the unique values. We have to store the maximum 4. Now we will try to store 3. Okay, so first of all, we will see that 3 is present or not. So 4, 3, 3, and 2 are the values. So 3 is present. Okay. So again, 3 is not less than 0. 3 is also greater than. So this condition will also not run. Answer plus is equal to 3. Okay. So 4 plus 3, that is 7 is our current answer. Then we will move to this particular index. This is containing 3 value. Okay. The second index. Then what I will do, our temporary variable is reduced by 1. That is from 3, it has become 2. Okay. So I will check that 2 is less than 0. No, 2 is greater than max of height of I. So 2 is greater than 3. No, it isn't. So this will also not run. So answer plus is equal to 2. Okay. So 4 plus 3 plus 2 would be 9. And then my temp variable will be decreased by 1. Okay. Again, this condition will not run. This will also not run. And answer will be incremented with 1. And temp variable will become 0. We will also come out of the loop. So, and the answer is 10. Okay. Now, if I see this particular example, see here you can see already is 2 to 1. That is already it is given in decreasing order only. Okay, so it will remain the same after the sorting. Answer is 0. Temporary variable is containing 0 initially. We are running the loop. I am checking whether 2 is greater than less than 0. No, it isn't. So I will not return -1. If temp that is 2 is greater than equal to 2, greater than 2, then it will not run. So answer plus is equal to temp. That means answer is currently holding the value 2. Okay, then I will move to this particular index, and temp was initially 2. Now temp has become 1. Okay, in order to maintain the unique store unique values. Okay, so temp is 1 now. So now it will check 1 is less than 0. No, so it will condition will not run. Temp that is 1 is greater than maximum height of 1, that is 1. No, it isn't, so nothing will happen. Answer plus is equal to 1. Okay, and then temp, that is temp is 1. Then temp will be decremented by 1. Temp has become 0 now. Okay, now what I will do is if temp is less than or equal to 0, yes, is that means what? There are no positive values left. Okay, that means all the unique values that were positive has been taken, so we cannot proceed further. So basically, at this particular index, that is 2 index, we will return -1. Okay, hope you have understood this problem. So the only logic is you sort it in decreasing order, take the maximum value first, try to decrease it by 1, and also at this particular condition, that is, suppose if the maximum height temp is greater than maximum height of I. Okay, that means suppose the values are 4, 2, and 1. So 4, we will first take 4, then temp will contain 3, but 3 is greater than 2. Okay, so maximum for the first index, the value is 2, but temp is holding 3. So 3 is greater than 2. That means we have to update our temp with 2. Okay, because it was given that you cannot take the any value that is greater than maximum height of ith index. That's why. Okay, so this condition I have taken here. Else it is a simple code. Now if I run it, if it is running successfully, and you can see it is already accepted. So hope you have understood this problem, guys. If you like this video, give me a thumbs up and subscribe to the channel. See you in the next video. Till then, goodbye.